So hello friends, welcome to our YouTube channel, and today we are going to talk about the Laplace transforms. So Laplace transform is a function defined for all positive values of the t. Then Laplace transform is denoted by like this. Okay, it is denoted by f of t or f bar of s. So this is a general form in which the Laplace exists. So here we see a s here. S is called a real or a complex number, right? Next, coming to the question. So this is an important mark, and this can be asked for the 1 mark in the part A for the JNTU paper. So let's see what is there it is. So f of t must be piecewise or sectionally continuous in the given interval. Okay, then what is the condition? 0 is less than a, less than or equal to t, t is less than or equal to b. Okay, then f of t is of exponential order. Okay, now so these all are okay. Yeah, this is an important one. A function of f of t is said to be of exponential order if limit t tends to infinity, e power minus f of t is equal to a finite number. Okay, this is an important point, note it. Now let us know how a Laplace transform of some elementary functions. What are these? So generally we know this is a general form in which the Laplace exists. So by using this form we are going to reduce some of the elementary functions, right? So let's get started. So f of 1, using the general form, f of 1 f of 1, so 1 here. Then we know integral of e power ax, so we are applying this formula. Then integrals, then we get minus, like that only. We have many formulas like that, so I think these are not so important. Yeah, in this, one of the most important thing we see is about the gamma function. So the formula is this one. Yeah, so these are some of the gamma functions, properties of the gamma functions we see. You can see this clearly, and if you want you can take a pic of it. Yeah, now let me show you all the formulas of these categories. I did not show all of them one by one, but I will show you all at a time. Okay, so these are the functions, Laplace elementary functions. You can take a pic of it, and we'll move on to the problems, and we will use these formulas to solve those problems. Okay, yes. Okay, now let's start with the first problem, that is t square plus 1 whole square. We have to find the Laplace transform of this. Okay, now how to find? So you can see this, it is of a form a plus b whole square, right? We know that a square plus b square plus 2ab is a formula. So apply this for this. What we get? T power 4 plus 1 plus 2 t square. Now we got this, and we have to substitute. We have to place this here. Then t power 4 plus 1 plus 2t square. Now dividing the Laplace transform for each term. Okay, now we can see this, what it is. It is a form t power n, which is n factorial by s power n plus 1. So this is the formula. So let's apply this. So here, what is n here? 4. So we can write like this. So 4 factorial by s power 5 plus Laplace transform of 1 is 1 by s Then again same, we are using this one. Then we get 2 factorial. Now n is equal to 2, that is 2 factorial by s power 3. Now 4 factorial is a 24 plus 1 by s plus 2 into 4 by 2 by s power 3. Then what happened? Now the problem you can end till here, but if you want further substitution, let me show it. So we can take s power 5 common and we get s power 4 plus 4 square plus 24. Yeah, so this is the final one. So yeah, you can take a look upon this problem. Yeah, it is clear. Right, we'll move on to the next one. Second one, Laplace transform of e power minus at minus 1 by a. So now what we can do here is, here this is an unwanted thing, we don't know. So what we do is we will separate from the main function. So we can divide it like this. We will divide each term. Okay, then we know what is this formula. It is 1 by s plus a, right? If minus is there, we use plus here. Okay, minus. What is the Laplace transform of 1? It is 1 by s. Then we can substitute it further. S of s plus a, s minus this get cancelled and a also get cancelled. What will be there? 1 minus s of s plus a. This is the answer. So you can see this. So now before starting to the another problem, I would like to drag your attention to these trigonometry formulas. So once revise these formulas, it will be very helpful to you. Yeah, especially in this Laplace transforms, it will be very helpful to you. So once look at these formulas. Okay, so in the previous video I have shown some of the formulas regarding trigonometry functions, right? Now let us see how we will implement these type of formulas into the Laplace. So here they have given a question, that is the Laplace transform sin 2t into cos 2t. Yeah, if it is plus, then we can use normal individual formulas of Laplace sin AAT and cos AAT. But here the multiplication format is given, so we have to use sin A and cos B type formula, which I have already gave you. So actually we have a 2 sin A cos B formula, which is a sin of A plus B plus sin of A minus B. But we have here sin A and cos B, so the 2 went this side, then we get this formula. So now here where A is 2t and B is t, converting this part to this part, we get 1 by 2 of sin 3t plus sin 2t. Then now we got a addition format. Now we can apply separate individual Laplace elementary functions, right? Now Laplace transform of sin 3t plus Laplace transform of sin t. Laplace transform of sin 3t is 3 by s square plus 9. So here sin means, what is the formula? A by s square plus a square. What is the a here? What is the a here? 3. So a is 3. So 3 by s square plus 3 square is a 9 plus sin t. Again a is a 1 here. So 1 by s square plus 1. Now completed this problem. You can take a look on it. Okay, now let's do the typical one. Laplace transform of cos cube 2t. Now how to do this? So if you see here, the function f of t is cos cube 2t. How we can get this? So now what is the cos 3t formula? It is 4 cos cube t minus 3 cos t, right? Here t is 2t. What happens now? Cos 3 2t is equal to 4 cos cube 2t minus 3 cos 2t. Right? So now we want this term, right? So now what happens? Cos 60 plus 3 cos 2t is equal to cos cube 2t 1 by 4, right? So now applying the Laplace transform of cos cube 2t is equal to 1 by 4. Now separating these terms, cos 60 plus Laplace transform of 3 is a constant, we will take outside, cos 2t. Now 1 by 4 of cos 60 means, what is the formula? S by s square plus a square. Here a is 6, so 6 square is 36 plus 3 into cos 2t. Now here a is 2, s by s square plus 2 square 4, that is, we can leave this till here or else we can continue solving. If we take first this one, 3 by 4 into s by s square plus 4 plus 1 by 4 into s by s square plus 36. Then we get s by 4 of 3 by s square plus 4 plus 1 by s square plus 3. That is s square by 4, 4s square plus 112 by, so we are doing this whole process, s square plus 36. Yeah, till here the answer. You can take a look on it. Now coming to the next question, 6th one. Sin t plus cos t whole square, Laplace transform. Now we know that a plus b whole square format, this is of a plus b whole square, right? Now we will do this. Sin t plus cos t whole square is equal to sin square t plus cos square t plus 2 sin t cos t. Now what is the value of this? It is 1 plus, what is this 2 sin a cos a? It is sin 2a, so sin 2t it is. Then applying Laplace transform, sin t plus cos t whole square is equal to Laplace transform of 1 plus sin 2t. So Laplace transform of 1 plus Laplace transform of sin 2t. Laplace transform of 1 is 1 by s and sin 2t is 2 by s square plus 4. So we can end up till here or else we can continue solving this problem. Now let us see another question. Cos t, cos 2t, cos 3t. We have to find the Laplace transform of this. So now here this is the f of Laplace transform of this. So here f of t is cos t cos 2t into cos 3t. How to do this now? So what we do is here we will change this function to the cos a cos b. Okay. So what we do is 1 by 2 cos t of 2 cos 2t into cos 3t. So what we get is 1 by 2 cos t of, now what is the 2 cos a and cos b formula? 2 cos a cos b, 2 cos a cos b formula is cos of a plus b plus cos of a minus b. Okay, this is a formula and we are going to use this one. Okay, here now we get cos of a plus b, 2t plus 3t, it is a 5t, cos 5t plus cos of 2t minus 3t, cos of minus t, which is a cos t only. Okay, then half of, now multiplying this we get cos t into cos 5t plus cos square t. Okay, now again multiplying 2 to get the formula for this, or else directly we can use another formula like 1 by 2 into 2. Again it is a formula, a format of a cos a cos b. We want, it is a formula cos a cos b. Here 2 will go this side, so it will become 1 by 2. Okay, so 1 by 2 into cos t into cos by t. So yeah, cos 60 plus cos 40 plus cos square t. So 1 by 4th of. So here we have taken the 2 common from here and we have taken this 2 this side, so it is applicable to this one. So we have kept this 2 here out of this. So now 2 is here, that means another 2 should be there here. So what we get is cos 60 plus cos 40 plus 1 minus cos 1 plus cos 2t. Okay, this is of this one, that is equal to 1 by 4 plus 1 plus cos 2t plus 1 by cos 40 plus cos 60. We have written this in order. Now this is the final what we got after substituting the total part. Now let's see the Laplace transform of the whole part. Okay, Laplace transform of cos t into cos 2t into cos 3t is equal to 1 by 4th of. Now I am writing it in an individual format. Okay, Laplace transform of 1 plus Laplace transform of cos 2t plus Laplace transform of cos 40 plus Laplace transform of cos 60, that is equal to 1 by 4. Laplace transform of 1 is 1 by s, cos 2t is s plus s square plus 4 plus 40 is s square plus 4 square is 16, 60 is s by s square plus 6 square 36. So this is the final answer. You can take a look on it. So yeah, now before starting another problem, now let me remind some hyperbolic function formula, important formula. So that is sin hx is equal to e power x minus e power minus x by 2, and cos hx is equal to e power x plus e power minus x by 2. So these are the hyperbolic formulas which we will be using in the Laplace too. So regarding this formulas, we will be solving a question. So let us see. So Laplace transform of sin h cube 2t. It is a, now what is this meant here? It is a sin h x type, right, where x is equal to 2t. Okay, now let's see what happens. So we can write it as x e power x, so e power 2t minus e power minus 2t by 2. Now it is a cube here, so we'll keep whole cube. They asked about the Laplace transform. Okay, now 2 cube is 8, so 1 by 8 we will take outside. Then Laplace transform of, now a minus b whole cube format. It is of a minus b whole cube. What is it? So yeah, what is a minus b whole cube formula? It is a cube minus 3a square b plus 3ab square minus b cube. So now we'll use this formula to write this in this format. Okay, then we get e power 60 minus e power 3 into e power 2t plus 3 minus 2t minus 60. Yeah, now we will be writing an individual terms. Now completed, done, almost done. Our part is almost done. We will be writing individually. So no, e power 60 here positive, that means here we get negative. A is 6 minus 3 into, the formula is 1 by s plus s minus a, so here a is 2. Again here negative means we get positive in the denominator, that is 3 into 1 by s plus 2. Again minus e power minus 60 negative, so a is 6 here. Done. So we can end this till here. We can solve it furthermore. Let us see a nice beautiful question. Okay, f of t is equal to mod of t minus 1 plus mod of t plus 1. So where t is greater than or equal to 0. So here is a question. So now in this case we see mod here. Now we know that mod x is equal to minus x if x is less than 0 and x if x is greater than 0, right? Now using this condition, let's see. So we can write this condition like this also: 0 less than t less than 1. So if it is less, what happens for f of t? F of t will be minus of t plus t minus 1 in plus t plus 1. What we get is minus t plus 1 plus t plus 1 minus t plus t cancel, we get 2. Okay. Now what if t is greater than 1? If t is greater than 1, we are keeping this as it is. Then t minus 1 plus t plus, so we get 2t. F of t is equal to 2t. Now these are what we got when we use these conditions. Okay, let me write like this in a simpler way. T is equal to 2 when we got 2 when we used this condition. So 0 less than t less than 1, and when we get when we got 2t when we used this type of condition, right? Now we know the Laplace format, that is Laplace of f of t is equal to integral 0 to infinity e power minus st f of t dt. So this is a general form. I said before that it will be existing, and I said it is an important one. So here we are using it. So it is a general form. We will be solving the Laplace based on this. So now using this, now here we have a condition from 0 to 1. So we'll keep 0 to 1 and e power minus st. Here f of t is what? 2 dt, plus again from 1 to t is greater, we said t is greater, up to where we don't know. So up to 1 to infinity, e power minus st, and f of t is 2t dt. So I hope you understood this one, right? Now what we got is integral 0 to 1 e power minus st 2 dt plus integral 1 to infinity e power minus st f of t dt. Then here we need to do integration. So for this we know that 2 can be taken common, and e power ax, integral e power ax is e power ax by a. So here e power minus st, here a is minus s. We know that formula, integral e power ax dx is equal to e power ax by a, right? Now where a is equal to minus s, what happens is e power minus st by minus s from integral 0 to 1. Done. Then here f of t 2t, this is a 2t. Then what we do is we will take outside this one, 1 to infinity e power minus st t dt. So now the simpler trick we do whenever we get this type of problem. So when we get e power minus 4t or minus 60 or 8t normal, when we get in this form into t, like this format, when we get, what we do is, so what we do is we will take differentiation and integration. So here using isolate. Now here this is the exponential, this is a variable, that is algebraic. So first algebraic come first, means differentiation should be considered for the algebraic, that is t. Now integration should be considered for the e power minus st, so e power minus st. Now when we do differentiation of t, we get 1 differentiation of 1 0. We have to do this until we get 0. Understood? Now here also, now e power minus st, as we said the formula here, we will be applying the same here. What we get? E power minus st by minus s. Again e power minus st by s square. Okay, so this is the trick here. What we do? Plus minus plus. This steps will be repeated until the 0 only. Okay, till 0 only we will do this. Okay, we'll multiply this both now. Now let's continue our step. That is 2 is equal 2 into e power minus st by minus s 0 to 1 plus 2 into t into e power minus st by s, t into e power minus st by minus s minus 1 into e power minus st by s square. We will be applying limits over here. Okay, this is the trick we will. So yeah, we reached up to here. So here if you see there is an infinity over the upper limit, so we will be not considering the upper limit for the infinity. Okay, just we will be considering the one for this function. Okay, so let's do upper limit minus lower limit we do. So we will be substituting in the place of t, minus s by minus s minus lower limit, so e power 0 by minus s plus 2. Now here upper limit, if I consider it as 0, because infinity we will be not solving at all because we don't know, so I will consider as a 0, and upper limit minus lower limit. What is the lower limit? We will be substituting 1 in place of the t, so here 1 e power minus s by minus 1 minus e power minus s by s square. So yeah, now e power minus s by minus plus 1 by s plus 2 into, now it is minus into minus, it will be getting plus e power minus s by s plus e power minus s by s square. Okay, now here from this I will be taking s common. So yeah, what we do is we will be taking 2 common, then e power minus s by s here minus plus 1 by s plus e power minus s by s plus e power minus s by s square, right? So plus minus gets cancelled. What is remained, we'll be writing 1 by s plus e power minus s by s square. Now from these both I will be taking s common, so at last and final we get e power minus s by s. So this is our problem. Now coming to the next problem, f of t is equal to t minus 1 whole square. T is greater than 1 and 0 less than t less than 1. So this is a question given. So in the previous question there is a one line condition. Based on that mod will be we have defined the f of t, right? But here directly f of t they have given, and we know the formula, that is Laplace transform of f of t is equal to e power integral 0 to infinity e power minus st into f of t dt, right? Now based on this we will be writing this function. Okay, now here t is greater than 1 means what? T is greater than 1 means there is a no ending, so we'll be writing like this, 1 by integral 1 to infinity, what function they have given, t minus 1 whole square. So e power minus st, f of t is t minus 1 whole square dt, plus now the condition they have given is 0 less than t less than 1, that means 0 to 1, 0 dt. Now as I already informed you that we will be not considering the infinity, we will be just considering the lower limit, right? So upper limit I will be taking as a 0. So yeah, here we will the condition appeared again. So what we do? So yeah, here it is an algebraic function, it is an exponential one. So in the islet a first comes, then differentiation, integration, the trick we have, which I said we have to apply it. Okay, t minus 1 whole square e power minus st, differentiation of this one, what happens? So yes, after doing the differentiation, what we get is 2 into t minus 1, and here again will be doing differentiation, because we have to do differentiation until we get 0 according to our trick. So it is a variable, so differentiation of x will be getting 1, so constant it will be 0, so 1 minus 0 is a 1, so again differentiation of constant is a 0. Now here doing the integration part, so e power, it is of format integral e power ax, so it is e power ax by a, so it is minus e power minus st by s. Again if we do the integration, here again we get minus into minus, that is a plus, so e power minus st by s square. Here again if we do the integration, what happens? We will get negative and s cube here, so minus e power minus st by x cube. Now writing so okay, and keeping the positive negative sign, and doing multiplication for the adjacent terms. Okay, so here you can see t minus 1 whole square into minus e power minus t by s I have done. Yeah, then minus 2 into t minus 1 into e power minus st by s square, then this one. Okay, now as I said you that we will be not doing infinity part, so we will leave the upper limit, and now doing the lower limit, so upper limit minus lower limit, so now we are not doing the upper limit not done. Okay, minus we are keeping here, and we will be continuing the lower limit. Here 1 is there, so we will be substituting the 1 here, so 1 minus 1 will be the 0, and the whole term becomes 0, and here coming to the next term, here t minus 1, that is a 1 minus 1 0, whole term becomes 0. Here we will substituting 1 in this part, so we will get this one. Then what we do is negative into negative we get a positive, so this is the final answer. Yeah, moving on to another problem, that is f of t is equal to sin t 0 less than t less than pi, and 0 comma t is greater than pi. So as now to solve this question, we know the formula, Laplace transform of f of t is equal to integral 0 to infinity e power minus st f of t dt, right? So now using this formula, okay, now first condition they have given is 0 to pi, so we'll be writing 0 to pi, then e power minus st, what is f of t here? Sin t, dt plus again. So t is greater than pi, that means the limit should be pi to infinity. Greater than pi means we don't know the value of it to where, so I'll be writing pi to infinity e power minus st. What is f of t? 0 dt. The whole term becomes 0 only here. So here we can okay, I have told the trick for the variables. Whenever we get the variables, then we will be doing differentiation and then integration. So whenever we get this type, exponential and the trigonometry type, what we do is we will be using one formula. So let me tell you that formula: integral e power ax sin bx dx. So this is a formula, that is e power ax by a square plus b square into a sin bx plus b cos bx. Yeah, oh sorry, here a minus b cos bx. So yeah, this is a formula. Okay, now here what is a is a minus s, b is 1. Okay, now using the formula and substituting, so e power minus st by what is a, s square plus what, b square 1 into what is a minus s sin what is b here 1 into t minus b is 1 cos b 1 t. So limits are there 0 to pi. Done. So now we will be applying the limits. In place of t we have to apply the pi. That means what we get is e power minus s pi by s square plus 1 into minus s sin pi minus cos pi. Now minus lower limit e power 0 by s square plus 1 into minus s sin 0 minus cos 0. Okay, now e power minus s pi by s square plus 1 minus s. What is sin pi? Sin pi is, so yeah, it is 0. Cos pi is minus 1 minus 1 by square plus 1 into sin 0 is 0, cos 0 is 1. Then what we get is e power minus s pi by s square plus 1, minus into minus plus minus, again minus into minus plus 1 by s square plus 1. Now writing as one term, what we get is e power minus s pi. This is what we get the answer. I think it is clear for you. Based on these questions, I want to give some homework. That is first one, find the Laplace transform of first one e power t when 0 less than t less than 5. 3 when t is greater than 5. Okay, this is f of t is equal to. Next, second one, f of t is equal to 1, 0 less than t less than 2 and 2 2 less than t less than 4, 3, 4 less than t less than 6, 0, t greater than 6. So these are the homework questions, and if you solve this, you will definitely get these Laplace transforms. Okay, you have to pause the video and solve these questions right now. Yes, you have to solve this right now. So after solving for first one, we get, I'm giving a final solution to check whether it is correct or not. So you will be getting this one. For the second one, we will get 1 by s and plus e power minus 2s plus e power minus 4s plus 3 into e power minus 6s. Yes. So now we will be doing another type of question, that is Laplace transform of root t plus 1 by root t whole cube. So here we'll be considering f of t part whole cube. We can write this as t power 1 by 2 plus, it is the denominator, will be signing up, then minus, it is of the form a plus b whole cube. Formula is a cube plus b cube plus 3a square b plus 3ab square, right? So a cube plus b cube plus 3ab square plus 3 this is 3a square b plus 3ab square, yeah. Now we get minus 3 by 2 plus t power 1 by 2 plus 3 t power minus 1 by 2. Now applying the Laplace transform of root t plus 1 by root t whole cube is equal to Laplace transform of t power 3 by 2 plus Laplace transform of t power minus 3 by 2 plus 3 into Laplace transform of t power 1 by 2 plus 3 into Laplace transform of t power minus 1 by 2. Now as we know t power n formula, so as these are in the fraction, we will be using the formula gamma of n plus 1 by s power n plus 1. So this is a formula. Then what we get is gamma of 3 by 2 plus 1 s power 3 by 2 plus 1 plus gamma of minus 3 by 2 plus 1 s power minus 3 by 2 plus 1 plus 3 into gamma 1 by 2 plus 1 by s power 1 by 2 plus 1 plus 3 into gamma of 1 by 2 plus 1 by s power minus 1 by 2 plus 1. Okay. Now here from the properties, gamma of n plus 1 is equal to n gamma n. Okay, now particularly if we take this part, okay, I will be doing here only. Now particularly if I take this part, now what is n 3 by 2? Gamma of n. So 3 by 2, here we have to get 1, until 1 we will be doing. So 3 by 2 can be written as 1 by 2 plus 1. Again this can be, it is of the form gamma of n plus 1, again we will be applying this one. So 3 by 2 into 1 by 2 into gamma of 1 by 2. Now there is no chance further to deduce this part, and as we know, gamma of 1 by 2 is a root pi. So that's why I said properties are more important. Now this next step will be 3 by 2 into 1 by 2 gamma of 1 by 2. The same term I have written this here. Again, this will become s power 5 by 2 plus. Now the same process will be repeated. Then what we get is minus 2 root pi by s power 1 by 2 plus 3 into 1 by 2 by 2 s power 3 by 2 plus 3 2 by s power 1 by 2. Then 3 by 4. Now what I said, the value is root pi by s power 5 by 3 minus 2 root pi s power minus 1 by 2 plus 3 by 2. The value is s power 1 by 2. So this is a final answer. You can take a look upon this problem. Totally here, I hope that you have understood how to use elementary functions in the Laplace transforms, right? So now based on these elementary functions, I have given 5 questions to you to solve as your exercise questions, and you have to solve it, okay? And winding up this video, and thank you friends.